Fundamental theory of direct current. Column comb. The practical unit of the quality of electricity of the column is the comb. The quality of electricity flow per second at any point of the circuit when the current strength of 1 amp. The designation of the quantity of electricity is letter Q. Ampere hour. The comb is a very small unit of the quantity. Is really an ampere per second of electricity. Large unit of the ampere hour. This unit is practice is the quantity of electricity flows per hour at any point of the circuit. Which when the circuit current strength is 1 ampere, the capacity of the battery is rated in the amperes hours. The capacity of the condenser, electrical capacity of the condenser's electrical apparatus used for the storage electricity. The original condenser was a Leyden jar. As previously explained, it was found to retain the electricity. At present time, the time condenser are made in different forms, but consistency of two or more metal plates separated in a narrow gap of the air insulating material called the dielectrical. Simple condenser A, B, and C, as in some of the condensers consist of a piece of tinfoil oil paper between another type of which the very familiar with the variable condenser uses the radios, which consist of the number of plates that move between the number of one of the other plates using the air of the dielectrical. Figure 27, the closing of the circuit of the cell A, the charge of the plates B and C. If the voltage of B and C becomes the equal of the voltage of C, B receives the positive charge of the C, the negative charge, the greater of the air. The plates near they can be placed each over there without causing. The spark to be jumped across the grid of the quantity of electricity the place will hold. The electricity will increase when the charge of the place will be disconnected with the battery will retain the charge insulated with the condenser discharge with the connecting units placed together, thus reducing them some potential. Dielectrical strength of the insulating substance can be tested by the condenser. The thin layer of the material is placed between the two conducting plates with the voltage built up in the plates until the metal breaks down and the spark which burns a hole through it. The difference of potential will just be preceding that which punctures the breaking down of the insulation determines the value of the dielectrical strength of the insulating material. Alright, units of capacity. The unit of capacity of the condenser is measured with the quantity of the electricity which must be charged in order to raise the electrical potential from 0 to 1 volt. The practical unit of the capacity is a farad. The condenser, the capacity of 1 farad to 1 column is necessary to raise the potential from 0 to 1 volt. The farad begins with the unconventional large of microfarad, which is 1/1,000th part of a farad. Generally used the practical work of the designation capacity of letter C. Electrodynamics, electricity, mechanical motion, dynamos, and motors. Reviewing magnetism, static electricity. Electrical current is found with artificial magnets and has been made with the natural magnets. Static electricity has induced the electrical charge on the other bodies and produced sparks when discharging between the bodies. Electrical current has been caused by the chemical change that has been converted with the coil wire into the magnet, whose strength is great and increased with the core of the soft iron. When it is discovered the cutting magnet lines of force, the conductor produces electromagnetic force and loops the coils of the wires arranged to revolve around the axis between the two magnetic poles is cut with the magnetic lines of force of the generated electromagnetic force, which is coil then pressed upon electrical surge made to be worked with it. If the loops of the coils were rotated continuous external mechanical forces, it was possible to collect the electromagnetic force generated, either alternating direct voltage depending upon the arrangement of the collecting of apparatus. Direct current has unidirectional voltage. If the current flows constantly with one direction, positive and negative. Alternating current has the voltage of periodic fluctuation. It starts with 0, rises with the maximum value in one direction, falls to 0, rises with the maximum value of the other direction, and again with the falls to 0 at the start of the entire process over again. The period during which the one direction caused the alteration, while the entire period made up of one positive, second, and negative alteration is called one cycle. The electrical machine has the revolving loop. The coils described above transform the mechanical energy to use to revolve the coils with these electrical energies called the dynamo or generator. When the operation was reversed, the current set through the coils and loops, it was found that they resolved the transforming electrical energy into the mechanical energy. This later machine is called an electrical motor. Motion has been produced previously. Magnetic attraction, armature magnets, movement of the iron core of solenoids in later years. The magnets have been made to pick up the tons of the magnetic substances, and solenoids have been used for the signal to operate more signals and training stop the trip type. Energy power. The energy of the working electrical current with the generated with the converted into the light energy, the late energy, the chemical energy, the mechanical energy, the power is rate and the charge energy for the one form or another, the time rate of doing the work. Unit of power is found to be the experiment of the power in any part of the electrical circuit, proportional product of the electrical motor force in terminals with the amount of the current flow. The amount of power generated with electrical motor force is 1 volt, causing the current of the 1 amp to flow. For the unit of the quantity of the power is called the watt. The kilowatts is the large of the power, equal to 1,000 volts. 746 watts current correspond to 1 horsepower. The designation of the for power is letter P. Since the previously brought out poor power's rate of the transformation energy from one form to the other, this follows the amount of energy transformed and equals the product of the power of the time of the transformation. When the power of the rate of which the work is lettered to be done 1 y, then the work done with 1 second is 1/1 y, which is called 1 joule. The joule of the unit of the energy, the watt of 360 joules is often, while the still is often used, while still larger unit is kilowatt hour. The joule is represented with the letter W. Unit of heat, the metric system in the unit of heat, the gram calorie, which is the amount of the heat necessary to raise the temperature on 1 gram of water through the 1 degree centigrade. The British system unit of heat, the British thermal units, which is the amount of heat necessary to raise the temperature of 1 pound of water through 1 degree of Fahrenheit. This shows a conversion table of power, energy, heat of units to the horsepower, to the feet, and mechanical watts and BTUs. With the horsepower per hour of kilowatts, joules, and BTUs, and mechanical more powers. Power formulas show the volt times the amps times the ohms and how they've changed in their different ratios. Horsepower is power divided by 746. Power is equals horsepower times 746. Energy distribution. Notice that the number of the watts may be found either the multiplying the voltage E with the current with multiplying resistance the R with the current of the square. The P power is equal to volts times ohms. E energy volts times amperes ohms power times ohms squared times or amp squared times resistance, amp squared times the resistance power of the watts required, force the current through any circuit that allows all circuits to have the sum resistance of the power is transformed into the heat. Power loss and resistance. Electrical current flowing through the conductor dissipates the energy as heated, but the conductive effects of this like friction. Electrical energy is converted to heat energy and loss the voltage necessary to current. The flow is like a flow of necessary to move a body with resistance or friction called the resistant voltage. Proven for that from a direct current, the resistant voltage of a solid liquid conductor depends only on the current and upon the dimension, upon the material. The physical state of the conductor has no relation to the property of the external conductors, surrounding insulators, nor external circumstances. The power is in the heat produced by the resistant voltage and the current, or P hour times voltage times ohms. In the producing the paragraph, it is noted that the heat loss can be prevented with the power times ohms squared times through watts amperes squared times ohms. The power loss of wire is the resistance of proportional square of the current. The heat loss is used by the I equals R loss. I squared times R loss. Electrical distribution system. Figure 28 shows the electrical distribution system of the generator into a powerhouse, sending the power through the transmission line with the factory. Though there is a load of a meter and light of the heater, illustrating the conversion of electrical magnetic energy, light energy, heat energy, storage of battery charge with represent the conversion of electrical energy to chemical energy. The powerhouse of the factory generator voltage, amperes, and motors, and the whatever symbol across the resistance. In the powerhouse, the voltmeter indicates 100 volts between the positive and negative conductors. The ammeter indicates the output of the 10 amperes of the conductor. A is the power generated, the number of the watts produced for the obtained with using the power. Power equals E times I, or P is equal to 100 times 10 equals 100 watts or a kilowatt. Drop of the voltage in the line. Drop of the voltage in the line used with the formula E equals IR. The resistance of the line of the both conductors between the powerhouse. The factors EO, 2O. The drop of the voltage line between the powerhouse and the factory 10 times 2, 20 volts. The voltage in the factory 10 minus 20 volts is 80 volts. Loss of the power of the heat of the transmission line. Loss of energy of the heat of the transmission line obtained the use of the following. The P equals the I squared times R, or P equals 10 times 10 times 2, or 200 watts. Therefore, the power is consumed with the carrying of the current with the power of the house of the factory through the combined resistance of the positive and negative conductor being converted with the heat and dissipated with the 200 watts. The conductor is not large enough to carry the current. Therefore, the resistance is high and has consequently high I squared times R loss is to be heated with enough burn insulation of the conductor. In order there may be not any overheating of the conductor, that whatever the produced and the radiated with the safely and insulation with the conductor's amount of the current is limited with a certain size of the conductor with a certain insulation shown in the following table. Allowable contingencies, current carrying capabilities, capacities of the cables, copper wires and cables of 98% of conductivity. Power consumed on lamps. When a lamp is rated at 50-watt lamp, the 110 volts, that means the burning of the 110 volts it consumes 50 watts. The current used is I equals P divided by R. P equals R. Or amperes equals power times volt divided by volts. Power times volts is equal to 0.5 amperes. Ohms is equal to voltage over the amperes. Resistance of a lamp is constant. At 100 volts consumed with the equal to P equals the volt squared times the ohms divided by the ohms, or 100 times 100 equals 200 divided by 242, 41.14 watts. Actually, the resistance of tungsten lamps describe the reduction of the voltage. Actual watts of 100 watts above example would be somewhat higher than 1.4 watts. Information contained herein does not represent the entire subject converting the fundamental theory of the direct current, but it does not represent the portion of the clearly understood which enable the person to practically deal with the application of signal of the laws governing the direct current phenomena. American Railway processes, principles and practices, Manual&Control, and fundamental theory of control. Alright, and then it goes through the questions, guys. So, like, I'll be splitting this and putting it on my OneNote teaching thing for railroads. There's actually 100 different questions, so this is going to be a good question test. Thanks for listening. This is American Railway Signals, Principles, and Practices, Chapter 22, Manual Control, Manual Block System, and Fundamental Theory of the Direct Current.